Hello, everyone. My name's Gretchen Rowe, and it's my pleasure to spend a little bit of time with you talking about what is your child's math ability. I know often as homeschool parents, this is something that we struggle with. And I have to say that it was the greatest obstacle for me becoming a homeschool parent. I actually had no intention of ever homeschooling my children, but the good Lord had a different plan. And when my eldest daughter was in third grade, I was told through her that the school had decided there was no need for her to memorize her multiplication tables. And I knew I was a weak math student. I was always a hesitant student, and I knew that foundational math skills would be really essential for her. So that actually launched our homeschooling journey. And now she's 35 years old. She is a college graduate owning her second business and counts her homeschool experiences as some of the best times of her life. So today, I have been asked to share specifically with you about how would you evaluate a Math-UC curriculum and what does it mean for a student to have math ability? And I just love the title of this presentation. I think it's very clever. I think it's very true. And I'm delighted that Sunlight has asked me to share with you. So I'm going to share my screen, mainly because the PowerPoint's going to keep me on track. And we're going to talk a little bit about what it means to have math ability and how you might weigh as a homeschool parent a Math-UC experience. So let's get started. I am a representative for Math-UC. I am our special needs placement consultant. I have been here for 7 years, and I have to say that it has been a tremendous privilege to work with hundreds of families as they have navigated the process of beginning a Math-UC journey or to walk alongside them as they continue their Math-UC journey. It took me 6 years to find my way to Math-UC, and I was probably on curriculum number 6 or number 7. I will tell you that we have, in our 21 years of homeschooling 6 children, used at least a dozen different mathematics curriculum. But I continue to think that Math-UC is the creme de la creme because it empowered my children to begin the process of learning how they learn best and to advocate for themselves. And if you're a brand new homeschooling parent, learning that self-advocacy is an absolutely vital component of being a successful homeschool student. So let's talk a little bit about why Math-UC is different. And really what I want to do is outline for you the difference between mastery and incremental, or what you'll often hear in homeschool circles is spiral approach. Which approach is best for your family? And not every shoe fits every foot. So what I'm going to tell you here will be information that you can take and digest accordingly. Let me explain, however, what's the difference between these two approaches. In an incremental approach, someone has decided in advance what your student needs to know in order to be mathematically successful. So in any given topic, that student has the opportunity to see pieces of a whole. What do I mean by that? Let's say we're talking about the addition of fractions with unlike denominators. In an incremental approach, the developers of that curriculum have decided in advance how many times your student needs to see that process and to what depth your student needs to see that process to have an understanding of how to add two fractions that have different denominators. What happens if the decision of the developers is that your student needs to have 3 interactions with instruction in that process to be thoroughly skilled in that process, but at the end of those 3 instructions, your student doesn't have mastery or doesn't fully comprehend how to add 2 fractions with unlike denominators? What are the implications there? Well, long term, it means they're going to struggle in algebra because being able to be wholly proficient in fraction manipulation is one of the keys to algebraic success. So, how do I know? How do I figure out if I'm using a spiral or an incremental approach that my student fully understands something? Well, hopefully they'll do well on tests. Hopefully they'll do well on those experiences when that math comes up as a surprise, which is really how math comes to us as adults. And hopefully they'll continue to do well as they progress forward. What happens if that doesn't happen? And that's where Math-UC's approach is entirely different and I think tremendous. A mastery approach means that you're going to learn mathematics one concept at a time. And in the process of learning that concept, there's going to be an opportunity for your student to teach back to you what they have learned. And that really is the highest form of learning. If I have to be prepared to explain to someone else how to do something, I'm much more likely to be engaged in the process. I'm much more likely to engage both halves of my brain. And I'm much more likely to integrate that process so that if it comes up again, I have a full understanding of that. And that is what makes Math-UC a wholly different experience from other math curricula. So let's talk a little bit about what Math-UC is. Well, we are a manipulatives-based program. That means we strive in every opportunity possible to use mathematical manipulatives to instruct a student successfully. And I'm going to talk a little bit more about that in a moment. What does it mean to be mastery focused? Well, as I've explained, it means that you instruct each concept to a student, and that student practices with that concept and then instructs it back to you. We're also conceptual, and being a conceptual experience means that student not only knows the trick, but knows why the trick works and can apply that. If a student has true conceptual understanding, even if they forget a formula, they know the goal they're trying to reach mathematically, and they can still get there successfully. At Math-UC, we also place an emphasis on fundamental skills. What do I mean by that? Well, the fundamental skills are the foundational building blocks for mathematics. And often we encounter older students who have a weak set of fundamental skills, and then they get up into higher mathematics and they struggle. And we wonder, well, is it the higher mathematics that's a struggle? Are they just not math oriented? Or what's wrong? And the vast majority of the time, I can tell you that if a student is weak in a fundamental skill set, then those subsequent skill sets are also weak, because math is incremental and it builds upon itself. Here's the last important part of a Math-UC experience, and that's what we call parental engagement. There are mathematics programs that tell you you don't have to do anything except put your child in front of a computer and enjoy the fruits of their efforts. But I have to ask you, in all honesty, how often in your experience have you felt that that was a successful one? Even as adults, when we sit down to a computer, if we don't have the chance to assimilate what we're learning, have a conversation with someone else, and verify our understanding, sometimes our learning is a little bit sketchy. And educational resources and research, cutting edge research, says that the best way to learn mathematics is still with paper and pencil. Why would that be? Well, because paper and pencil makes us engage both sides of our brain. It helps us experience math, and it helps us focus. So that parental engagement becomes a vital piece for you. Does it mean you have to sit next to your child with every problem for every moment of their mathematical day? Well, a little bit depends on their age. The younger they are, the more they're going to need your engagement. But mathematics in Matthew C's world is designed to help your child learn to self-advocate and to be able to focus on getting the mathematical job done. So that parental engagement is a vital component. Remember, I talked about teaching back to someone else? That's where you come in and you make it a terrific experience for your student to be able to teach back to someone and have a parent say, hey, you did a terrific job, is an absolutely important part of an academic experience. And isn't that why we're home educating our students anyway? So let's move on a little bit and talk about fundamental skills. The important thing to remember when we're talking about fundamental skills is, excuse me, I'm so excited. I'm losing my ability to speak correctly. The important thing to remember about fundamental skills is that they are sequential, that they build concept upon concept. They always build from a solid foundation. In any kind of mathematics instruction, whether it is incremental or mastery based, that solid foundation is so critical. And in mathematics, we never learn some wildly new thing for which we don't have some sort of framework to hang it onto. So building from that solid foundation becomes an absolutely essential component. Parents will say to us, I'm not sure where to place my student because you have these Greek titles in Matthew C, and I don't understand what the Greek titles do. And our Greek titles in our elementary series are actually critical to the process. And the reason they're critical is because as a mastery program, we don't teach mathematics at a grade level. We teach mathematics at a skill level, and that's entirely different. So in our Greek series, we are teaching math as a successive series of skill sets. Primer is our gentle introduction to math, and actually there's no mastery requirement with Primer. It's just a whole bunch of math explored for fun. Alpha is the earnest business of learning addition and subtraction facts and committing them to memory. What do I mean by that? If someone asks you your name, you don't think, what's my name today? You just reply with your name. And that's the kind of automaticity that is valuable mathematically for a student, not wholly apparent when you're 6 or 7 years old. But if you create that automaticity in a 6 or 7-year-old, then when they're engaged in a complex problem in Algebra 1, they won't have to step away from it to be able to complete that problem. They can be fully engaged in the process of that problem. So that's what we're about in Alpha, is committing those addition and subtraction facts to memory. But that's not all. We're also studying place value, and we're beginning the study of word problems, because word problems come to us every day in our adult life, and having a facility with that requires some time and experience. In beta, we take that mastered skill set of addition and subtraction, and then we apply it to everything else we do with addition and subtraction: time, money, measurement, addition and subtraction, regrouping to 3 digits. Then we progress in gamma to multiplication, and we teach multiplication from the beginning of skip counting all the way to the successful proficiency of being able to multiply 3 digits times 3 digits and have everything neatly packaged and correct in that process. We continue to teach word problems all the way through every level of math you see, because we want that automaticity and that proficiency. And here's something I think that's really interesting about math you see. Parents often say to me, ooh, my kids can do computational math, but word problems, they're tough. Math you see's word problems are designed to be solved using our manipulatives. And that is a different experience, because if the manipulatives can help you visualize what you're doing, then you have a more successful experience. Delta gives us the opportunity to teach the inverse of multiplication, and that's division. And let's face it, nobody wants to do division with a paper and a pencil if you have a calculator or a phone to hand. But Long division is the crucible by which we learn to estimate, and estimation is a valuable adult life skill. Once we've finished delta, then we've got all those core competencies of mathematics. So then we turn our attention to fractions, and we teach addition, subtraction, multiplication, and division in epsilon. Epsilon is our level that is designed to lay that solid foundation that creates a successful Algebra 1 student. And in my personal opinion, epsilon is the absolute most critical level of math you see. We do use manipulatives at that level, and we often have conversations because by the time you've reached the epsilon level, often kids are older and they say, I don't need manipulatives. But you know what? If you really want to demonstrate that mastery and you really want to engage in that teach back process that Math-UC does, then you definitely want to engage with our Math-UC manipulatives. The last level in our Greek series is Zeta. And in Zeta, we take that fractional skill set that we have learned in epsilon and we translate it to decimals and percents. And if epsilon is the most vital level of Math-UC, then Zeta, that's probably the most practical level of Math-UC, because as adults, we engage with decimals and percents every day. And so being able to have proficiency with that helps us give a student a foundation for adult life. Once we've moved into pre-algebra and above, then our scope and sequence looks very much like the scope and sequence you probably remember from school. Pre-algebra, algebra 1, geometry, algebra 2, pre-calculus, and calculus. There is some creativity in how you approach those levels. We have some parents who take algebra 1 and geometry and combine them in a single year. We have other parents who combine geometry with algebra 2. I was one of those parents, and I'll tell you, I didn't know how it was going to go, but it was a successful experience. You get to march forward in Math-UC as far as you want your student to go. And knowing that you're creating a successful mathematical student is a huge difference maker. So let's talk about a little bit why some math programs are more successful than other math programs. And I want to separate for you very briefly one of the reasons that Math-UC is different. The language that we use with mathematics is critical. And very often we create this adorable little girl quite by happenstance and accident, because we don't think about how the language affects the learning. Let me give you an example. In the number 325, if I say to a 6-year-old, tell me what number is in the ones place, that 6-year-old may or may not choose the number 5. I may say, tell me what's in the ones place, and they're looking for the 1. Where is the 1? So in Math-UC, we define the ones place differently. We refer to the ones place as the units place. And that way, when I say to a student in the number 325, tell me what number is in the units place, they know where to look. That's why the specificity of language becomes so important. Let me give you another quick example and then we'll move on. I'm multiplying 17 and 14. Oh, not multiplying, adding 17 and 14. So I have 17 on the top, 14 underneath it, and I say to my student, 7 plus 4 is 11. Put down the 1, carry the, most of us say carry the 1. And that can create confusion in a student because now I have 2 1s. Okay, am I clear that 1 is a unit or a ones place and 1 is in a tens place? So in Math-UC, we continue that specificity of language and we say 7 plus 4 is 11. Put down the 1 and carry the 10. And there, very briefly, we have made it more clear to a young student. Further, in the Math-UC world, we talk about the fact that there are no sleepovers in Math-UC, and everybody has to go home at the end of the night. So it gives a student a paradigm in which to frame why they have to carry that 10 into the tens place and come up with a correct answer, of course, of 31. I mentioned already about the best kind of mathematics instruction. And here very briefly is a graphic to tell you what the research tells us. The research tells us that the best kind of mathematics instruction begins with the concrete stage. What does that mean? Well, the concrete stage means to bring as many senses to the table as possible in the process of understanding mathematics. In the Math UC world, we call that build, write, say. So we build a math problem with manipulatives, and then we write it with a pencil, and then we speak it out loud, because in that process of developing that habit of saying it out loud, when the math becomes a little bit more complex and we're saying it out loud, that's how we begin to catch our own errors, and that's a valuable skill. Once we've explored math in the concrete stage, then we move to the representational stage. And the representational stage is, what's in your head? What do you see? And in the Math UC world, that's what becomes part of our teach back. In fact, in our mathematical interventions, we're very specific in requiring that representational stage and requiring a student to be able to explain to us what they see in their heads, so that we can replace an ineffective habit with a more effective habit. And those interventions are called aim for addition and subtraction and aim for multiplication. They're on the shelf behind me, and it's not my goal to talk about them today, but if you have a struggling math student, let me encourage you to explore these two interventions. The last stage in a mathematical experience is the abstract stage of math. That's where we use the Arabic numerals to prove our point, get our sum, create our product, and all of those things. But most mathematics instruction in the US starts in that abstract end of the equation. And that becomes a problem for students, particularly if they can't visualize that the number 4 means 4 units. So being able to help a student walk along this continuum is enormously valuable in the student's long-term understanding. Lots of math programs use manipulatives. Math UC is different in the fact that we use the same manipulatives from that first explorational stage of primer all the way through Algebra 1. And that continuity of purpose is tremendously valuable for kids long-term. At Math UC, we have 3 kinds of manipulatives. We have the integer block kit, we have the fraction overlay kit, and then we have the algebra decimal insert kit. And the integer block kit is part of your first purchase with Math UC. It comes as a universal set, comes as part of the universal set, along with the instructional and student components. And once you've purchased the block set, then you use that all the way through your Math UC experiences, as long as you're a Math UC family. You only actually need 1 integer block set for up to 4 children. In my family, I inherited my integer block set, and I still have it up here in my office on the shelf, even though I don't have any students using Math UC anymore. The truth is that integer block set becomes a valuable tool in your mathematical experiences. And whether you come to it by purchasing it through Math UC or come to it by finding it somewhere in the aftermarket, or like me, being gifted by a wonderful homeschool friend, we just want you to have mathematical success. That fraction overlay kit, that's for 1 level of Math UC. And that's because when we're talking about fractions, we're working with units less than 1. So I need something to help me understand how to represent something smaller than that. And as I've already said, I think epsilon is the most valuable level of Math UC. The algebra decimal insert is added to the integer block kit when we reach zeta, so that we can represent values less than 1. And then we can also represent values that are in base X, not in base 10. So together, all these manipulatives create that Math UC experience. So now what? Okay, Gretchen, you've given me some good information. How do I get to placement? Well, placement is again predicated on what your student knows. Parents will often say to me, how do I get to a third grade math UC experience? The truth is, you get to a third grade math experience by my knowing what your student knows. So there is a placement tool, and you can find that placement tool on the Sunlight website. I've given you the link here, but I probably should have broken it up differently. I didn't realize that it wrapped around differently. You know, the other thing that you have available at Sunlight is you have Sunlight's placement consultants, and they are amazing. I have the privilege to see some of them at homeschool conferences, and I have to tell you, they are a dedicated group of folks who have the desire to create a fantastic homeschool experience for you. So I would encourage you, if you're still scratching your head, what do I do? Who do I reach out to? How do I make this happen? And last but not least, if you have specific questions, here are my contact information. My name again is Gretchen Rowe. My direct dial phone number is right there. And of course, my email is there as well. It's been my pleasure to spend this time with you. In the last couple of minutes, I want to share with you some of the questions that parents share with us about how do I decide if Math UC is right for me? And here's what the way some of those questions go. The first one, the one we encounter more frequently is, I don't know if I can do this. I'm not very good at math. Well, let me tell you a story. I'm not very good at math either. And even though Math UC and all these math books that you see behind me have given me a level of mathematical confidence, I wouldn't naturally choose to do mathematics. In fact, if I'm really honest with you, I'm still not very fond of math. But Math UC enabled me to help learn right alongside my children. And what a tremendously powerful opportunity for you as a parent to model that teachability. There's nothing more powerful than to say to your student, you know, there are things I don't know, and there are things I still need to learn. So let's learn together. The second question I get from parents is, how long is this going to take? Because I really need to have an efficient math program. And the goal of a Math UC experience is for your student to spend about 15 minutes a day. Research tells us that a student who is in elementary school has a capacity to learn something new that is their age plus 2 to 3 minutes. So if you're thinking of your 10-year-old child, for example, their capacity to learn something new mathematically is limited to about 10 to 15 minutes. And I have to confess to you, when I first looked at Math UC and I looked at a math lesson in Math UC, my first thought was, well, that's not enough math, because in a Math UC math lesson, what we're looking at is a page that looks something like this. Let me pull a page up for you. Here is a Math UC lesson. We're looking at this lesson, and I have 4 problems here. And on the back side, I have 4 more problems. What do you mean, 8 math problems in a day? How is that enough math? My first impetus, or my first thought was, that's not enough math, because if you're weak in math, you've got to do more, but more isn't better. The truth is, there is value in a student having an engagement with math and then stepping away from that engagement and allowing the brain to do what the brain does best, which is assimilate what that student is learning. So being able to do that successfully is a tremendously valuable experience for a student. And what I want to say to you is that if you take the time to engage with your student and you engage with them properly, you're going to create a proficient math student. Well, Okay, Gretchen, I hear what you're saying, but I just don't have time to sit with them for every problem of every day. I agree with that as well. I was a busy mom of six, and some of my kids required more hatching than other of my children. In fact, I really had to wait until my last child before I got a kid who was a wholly independent learner who could take the reins and run with it. So, what is your involvement on a daily basis? Well, the first thing is the way Math-U-See instructs is we provide video instruction, and then we provide a lesson manual that guides you. The video instruction comes to you in two ways. It comes to you as a DVD, and it comes to you as an online component. So you have both of those things available to you. The way you choose to engage with it is up to you, but it's a 5 to 7 minute lesson. So it's not arduous. And there's one lesson per week or per subject. So there's 30 lessons in an academic season. And what if my child progresses faster? Well, that's terrific. We have kids all the time who do more than one season of Math-U-See in a year. They go through an entire level of Math-U-See and they're ready to move on to the next level. And every once in a while, I engage in the Sunlight Facebook group and the Math-U-See Facebook group, and parents will say, help, we finished math in March. What do we do for the rest of the year? You get to move on. Isn't that awesome? So that engagement that you have, that initial engagement, is necessary for two reasons. First of all, you know what your student is going to practice. Second of all, you are ready then when your student is ready to teach back to you. The first 3 pages in any Math-U-See lesson are designed for that practice. We don't expect a student to step into those practice pages knowing how to do it. The practice pages are to learn how to do it. And that practice can be their own. We encourage you, though, to engage with your student with the manipulatives until they can prove to you, okay, I got it. Let me go practice some more. The next valuable interaction that you have with your student is to be able to say, okay, let me know when you're ready to teach back to me. And when that happens, you know what? With a younger student, the language can sometimes be a barrier, but being able to use the manipulatives to help in the process of that language makes that teach back a surmountable opportunity, and it gives value to that student's experience. There's also 3 pages of incremental review, and that incremental review is absolutely essential. We call it systematic review. And so the goal is to review everything you've learned before. So sometimes parents will say to me, wait a minute, if you teach math only one concept at a time, how does it remain fresh with a student? And that's the secret to our systematic review. That allows us, as the student's math skill grows larger and larger, to give them more opportunities to engage with everything they've learned to date. And that mirrors what happens with us when math comes to us as an adult. The last thing we have as part of a Math-U-See experience is the test booklet. And in the Math-U-See world, the tests hold a very different experience. You and I have learned that testing says, here's what you don't yet know, but that's not the way it rolls in Math-U-See. In Math-U-See, our experience is that when you prepare to give your student the test, that student should do well on that test, because the expectation is that they have practiced the concept, that they've taught it back, and they have the confidence to do well. It also becomes your system of checks and balances, because sometimes you're going to give them that test and they're not going to do well. So then you know they don't yet know, and you step back into the materials. If you remember back in the original part of my explanation, when I was talking about incremental math or spiral math versus mastery math, that student that was learning how to add unlike denominators, and that concept was presented 3 times, and then the developers moved on. If that student needed to see that concept again, how did they get there? More importantly, how do you know they need to get there? In a mastery-based program, you always know what your student is learning. And to me, that is a critical, valuable piece of the academic process. I'm sure you have more questions, and I know that the folks at Sunlight would be more than happy to answer them. It has been my great pleasure to spend a little bit of time with you all today talking about Math-U-See. I wish you the joy of the journey. I wouldn't have traded the 21 years I spent with my kids here at my home for anything, and I hope you find it to be the same. Thanks for spending some time with me, and good luck. Happy mathing, everyone. Take care.